All right, let's talk about one of the most powerful, yet most difficult sources of clean energy on the entire planet: the ocean's waves. It's a technology that's been promising us this incredible clean future for decades, and now it might finally be on the verge of a real breakthrough. So, to kick things off, I just want you to look at this number: 2.64 trillion kilowatt hours. That is the theoretical amount of energy that crashes onto US coasts every single year. It's an absolutely mind-boggling amount of power, but to really get what that means, we need to put it into perspective. So, what does that actually mean? It means that, in theory, wave power alone could handle nearly two-thirds of the entire country's demand for electricity. That is huge. And it's exactly why so many experts see it as the missing piece of the puzzle for a 100% renewable grid. It's a consistent source of power, right? It's always on, even when the sun isn't shining and the wind isn't blowing. Which, of course, brings us to the big question. If there's so much potential just sitting out there, why aren't our coastlines already lined with wave energy farms? Well, it turns out that trying to harness the raw power of the ocean is one of the toughest engineering puzzles we've ever tried to solve. And it really boils down to two core problems. First, the ocean is just a brutal, brutal place to work. It's always moving, sometimes incredibly violently, and that salt water, it's just trying to corrode and destroy everything you put in it. But the second problem, the one that's even more fundamental, is hidden in the physics of the wave itself. Okay, so here's the core difference. Think about wind, or even a river current. They move in one direction, right? It's a simple, linear motion, and that's pretty easy to capture with a basic spinning turbine. But waves? Waves don't do that. They don't move in a straight line. They oscillate. The water goes up and down and back and forth, trying to turn that chaotic, oscillating energy into a smooth rotational force that can spin a generator. Yeah, that is a massive, massive engineering challenge. But a huge challenge like that, it tends to attract some really smart innovators. Right now, there is no single agreed-upon design for how to do this. Instead, what we're seeing is this really fascinating race between all these different companies, each with its own unique idea for how to crack the wave code. So let's take a look at a few of the leading designs. First up, we've got a Seattle-based company called Oscilla Power. They're developing something they call a two-body point absorber, and it's specifically designed to capture energy from all that complex motion we were just talking about. So how does it work? So picture this. Their device, the Triton C, has this float on the surface that just gets tossed around by the waves in every possible direction, up, down, side to side, you name it. But hanging underneath it is this really heavy ring that kind of acts like an anchor in the water, staying relatively still. And the secret sauce is the difference in movement between that chaotic float and that steady ring. That difference creates force on the lines connecting them, and that's the force that powers the generator. It's a really clever way to capture energy from all 6 degrees of that complex motion. Okay, next up is CalWave, and they're taking a completely different approach. Instead of trying to fight the crazy, turbulent surface of the ocean, their device operates entirely underwater, where the wave motion is actually a little more predictable. And the analogy they use to explain it is just brilliant. They say it works a bit like the regenerative braking in an electric car. So as waves pass over the top of the device, the changing pressure makes it move. And inside, there are mechanisms that create resistance against that motion, converting it into the torque that drives a generator. It's a really smart way to turn that oscillating undersea movement into usable electricity. And then we have our third example, eco-wave power. They basically looked at the brutal offshore environment and said, you know what? What if we just avoided it? Their whole strategy is to build on existing structures that are already there, like breakwaters and jetties. The big advantage here is all about simplicity and cost. The only parts of their system that are actually in the water are the floaters. All the expensive, complicated stuff, the generators, the computers, the hydraulics, it's all kept safe and dry on land, and that makes installation and, maybe most importantly, maintenance so much cheaper and easier than any of the offshore designs. So these are just a few of the competing designs out there, but what's really changing the game right now isn't just one single device. After decades of really slow progress, the entire US wave energy community is going through what you could call a seismic shift. And at the absolute heart of that shift is this: Packwave. You see, for years, one of the biggest roadblocks for any company in the US was just getting permission to test a full-scale device in the open ocean. It was a nightmare of red tape. Packwave solves that. It's a pre-permitted, grid-connected test site where companies can finally just plug their machines in and prove that their technology actually works in the real world. And backing up Packwave is a huge surge in funding. We are talking record amounts of federal money now flowing into marine energy. This isn't just a little bit of seed money anymore. This is a serious commitment from the government, with $25 million set aside just for the first companies who are going to test their devices at Packwave. So, okay, we have new designs, we have a world-class test facility, we have serious funding. Is wave power finally ready for prime time? Well, we're closer than we have ever been, but there are still some pretty major hurdles on the path to the grid. And this brings us to the real multi-billion-dollar question. Can a technology that has to survive in one of the harshest environments on Earth ever get cheap enough to actually compete? This chart lays out the challenge in really stark terms. Right now, most projections for wave energy are hovering around 80 cents per kilowatt hour. The target, to be competitive with solar and wind, is way down there, around 6 cents. That is a massive gap. And you have to remember, this isn't like mass-producing solar panels. Each one of these devices is like a custom-built fortress designed to survive a 100-year storm. All that complexity drives up the cost, and closing that gap is going to take major breakthroughs in manufacturing and efficiency. But even with that huge cost challenge, the U.S. Department of Energy has set a really ambitious goal. They want to have 1 gigawatt of wave power connected to the nation's grid by 2035. To put that in perspective, that's enough to power roughly 750,000 homes. It's a clear signal that they believe this cost gap can and will be closed. And we'll end on this thought from a pioneer in the field because it really captures the urgency of this moment. The technology is moving forward, the investment is finally here, but the real question is about time. Can we scale this technology fast enough to actually make a difference in our clean energy future? The power of the ocean is waiting for us, and the race to finally harness it has never been more critical.